What if I tell you that you could cut your Snowflake bill without touching your data? Espresso AI says it has cracked the code using LLMs and real-time warehouse intelligence. As we all know, Snowflake is very powerful, but it's not cheap. And as cloud data costs skyrocket, even the most advanced teams are looking for smarter ways to optimize without rewriting queries or sacrificing performance. That's where Espresso AI comes into the picture. Joining me today is Ben Lerner, CEO and co-founder of Espresso AI. Ben's background includes time at Google, and now his team is launching what they call Kubernetes for Snowflakes, a bold promise to dynamically route queries across warehouse and cut costs in real time. But how does it actually work, and why isn't Snowflake already doing this? Let's find out with Ben. Ben, it's great to have you on the show.
Great to be here. Thank you for having me.
It's my pleasure. Since this is the first time I'm hosting you, so let's start with the basics. What is Espresso AI and what problem led you to start the company?
Today, what we do is we help customers save money on their Snowflake bills and their Databricks SQL bills. So we are helping folks run their data warehouses more efficiently. The company is actually an outgrowth of what I did before this. I used to work at Google on systems performance. And so I was on a team of people who made sure that Google's infrastructure ran efficiently and scaled well. And really the goal for the company was using AI and ML to automate some of the work that we were doing and give everyone the ability to run their cloud backends the way that Google runs their data centers. Data warehousing happens to be a great place to start because I'm sure your viewers will know everyone is very stressed about their Snowflake bills. So we're trying to help with that. And the goal is to take the underlying technology and apply it to a lot more verticals in the future.
Thanks for sharing your story. Let's talk savings. How exactly does Espresso AI use LLMs to help customers lower their Snowflake bills?
So in a nutshell, you can think of what we've built as Kubernetes for Snowflake. We have an intelligent scheduling and routing system that analyzes your workloads in real time, understands what are the resource requirements and constraints of the jobs that you're running, as well as what are the resources that you have available in your data warehouses. So what do you already have up and running in terms of warehouses, or as people outside of data warehousing might call them, clusters, and tries to kind of match those together. Where the LLMs come in is that's what allows us to, on the fly, take a query and understand what those resource constraints and requirements are. And then our system will intelligently make usually thousands of decisions per day as different workloads come in to make sure that they are routed and scheduled as efficiently as possible.
Before we move forward, I would like to talk about you a bit. You have worked at Google. How did that shape your approach to building Espresso AI?
Yeah, so there's kind of two answers. In the very specific sense, I worked on two things over the course of my time at Google. I worked on machine learning and I worked on systems performance. And the machine learning portion of that was while I was on search. And at the time, I also did some research with DeepMind on applying machine learning to systems performance. So in a very literal sense, what we're building is an outgrowth of that research, of taking the idea that machines can quickly and efficiently understand what's going on in terms of compute, and use that to run things more effectively. That's kind of the narrow answer of my background. Specifically, there's also a little bit of a broader answer, which is Google's infrastructure is really well designed and really well built. I think many of the leading companies in terms of tech stack are coming out of Google or out of places that have been built with similar philosophies. And so what we're doing is really making that available to all companies, including companies that can't necessarily have 5 or 10 extremely senior engineers sit and re-architect everything for 2 years.
The main topic for today's discussion, as you also mentioned, is Kubernetes for Snowflake. How does this new feature work, and how does it save users money in real time?
Yeah. So when we say Kubernetes for Snowflake, what we're specifically talking about here is the type of scheduling that Kubernetes does. So this is basically what I was mentioning before. If you look at how a modern data center is run, at Google we use Borg. Externally, people use Kubernetes. When you spin up a job, you don't, with Kubernetes, you don't say, I'm going to put this job on this machine and it's just going to sit there and run. That's how people used to build software, and that's how many people still build software today. But a more efficient approach is to think of the different machines that your organization has as a set of resources. And then when a job comes in, there's an intelligent scheduling system that takes that job and puts it somewhere in your fleet. The really practical implication is if you're placing things manually, it's common to see 20, 30, 40% utilization. With Kubernetes, it's more common to see 70 to 90% utilization. So very rough ballpark number is you can cut your cloud infra bill in half by modernizing and making sure that things are scheduled appropriately. The analog to this is a variant of bin packing, which is an old computer science problem. And you can literally think of it as packing bins on a cargo ship or packing a moving truck, right? If you're careful about how you pack your boxes onto a moving truck, you can get a lot more in than if you just kind of throw things in haphazardly and then call a second moving truck. Most of us wouldn't do that in real life, and we shouldn't do it with our cloud infrastructure either. Coming back to Snowflake, this is scheduling and routing is exactly what we do. So the way that the product works is we sit between your human users and your tooling and your Snowflake instance. So we run over a proxy. You send your request to us, and when we get that request, we may change which warehouse it's running on. So exactly the same way that you would carefully and meticulously pack a moving truck, or very literally the same way that Kubernetes or Borg would pack your cluster to get those utilization numbers up. We pack your warehouses that may be running other jobs with incoming workload to make sure they're really efficient. The numbers I said before are pretty accurate. So we often see customers come in with 40 to 60% utilization. It's a little bit different from Kubernetes. It's a different style of workload. And we can often bring that close to 90%. So if you check out our site, it says save up to 70% on Snowflake. Those are real numbers that we see with real customers. And very common for us to cut someone's bill by 40, 50% by being able to do this. And really, it's just about using the hardware you're already paying for. But if you have it statically set up to, hey, this is always where the ETL jobs run, and this is always where the BI jobs run, we can be a little bit smarter and say, you have an ETL job running, but you have some spare capacity. You have a small BI workload coming in. We don't need to pay for twice as much hardware. We can run this on the hardware you're already paying for.
Now, here's the big question. Why isn't Snowflake already optimized for this? What gaps is Espresso AI filling?
I think the way that Snowflake has set up their system makes a lot of sense for something that was architected 10 or so years ago. It's a very natural extension of how you would build something if you were building kind of moving from on-prem to cloud, right? What people literally have on-prem is they have some set of machines that are running some workloads for this department. They have another set of machines that are running workloads to that department. And being able to translate that one-to-one makes the migration really easy. And in real life, there can be many more constraints to this sort of scheduling problem. You have to worry about data locality. You have to worry about availability. You have a lot more concern about who's paying for what, where. And again, it was also just on-prem systems are even older, so they were kind of architected before this best practice was well understood. So it's, I think, convenient for the sort of lift and shift of bringing on new customers, and it makes a lot of sense to people just getting started on the platform. But I think if you look at how would you build a system today, being able to build it in this way where you're scheduling things more efficiently makes more sense. The other kind of half of the answer there is one of the things that makes Kubernetes work well is that engineers annotate their resource requirements. So Kubernetes, rather than talking about SQL workloads, is centered around containers. So I would build some sort of service or maybe a batch job. I put it in a container. I say the container needs so much RAM and so much CPU and so much disk. And then that's how the scheduler knows, I'm going to place it here, here, or here. This is a little bit harder in SQL where these things aren't annotated. And so being able to use models to predict, hey, here's how long this query is going to run, and here's how long it's going to take to run given what's already running on that cluster, that really makes everything better and more efficient. So I would say it's a little bit of, us being 10 years in the future, and a little bit of the ML really does help this work.
Since we're talking about Borg and Kubernetes, let's talk about scale. How does Espresso AI perform for organizations with hundreds of Snowflake warehouses or multi-region deployments?
We generally perform better for customers at scale. So multi-region deployments, we do work per region. And this goes back to what I was saying about once you're in different regions, there are more constraints. We don't want to be sending a terabyte of data from, US East over to Europe or something. But in terms of having a larger Snowflake account with hundreds or thousands of warehouses, which some of our customers do, you're just going to see more returns to scale there. If you're running 2 warehouses, maybe you can compress them to 1, maybe you can't. If you're running 1,000 warehouses, you can almost certainly bring that down to 600 or 700, basically irrespective of how much optimization you've done yourselves. Because there's no, at that scale, there's so many different things going on. There's no static configuration that's going to be optimal. So it's all about taking a look at what is actually running right now, and where, I have some workload incoming, where can I route that workload, right? Based on this essentially unique series of workloads that are already running in my environment.
How easy or difficult it is to use it? Is there a learning curve? Do customers need to change how they write queries or structure data to take advantage of your optimization layer, or it fits seamlessly in their existing workflow?
This is not my first startup. And my first startup was integrating Python with Excel. So there's a very steep learning curve. And what I took away from that was you should make the product as simple and unobtrusive to use as humanly possible. So we put in a lot of work to make sure that engineers basically don't need to do anything. You can get set up in, from 15, 20 minutes to a couple hours, depending on how complex your environment is. All that's required is setting up a Snowflake account for us, which takes 5 minutes to copy paste a script, and redirecting your tooling. So you just literally change your URL from youraccount.snowflakecomputing.com to youraccount.espressocomputing.com. And then that's it. We run in the background. You don't need to worry about it. Your bill is just going to go down. Everything's going to get much more efficient. We, often talk to customers basically once a quarter when we have the check-in call. And most of our check-in calls are just, hey, how's it going? And people say, yeah, we basically didn't notice anything, but man, our bill is way down.
Of course, Kubernetes for Snowflakes is being announced today, but you do a lot of betas, you work with clients for pilots. Can you talk about some of the use cases that you see of Kubernetes for Snowflake, or if you can share some use cases of Espresso AI itself?
What we really do is help data engineering teams run Snowflake more efficiently. And the kinds of the customers where that goes really well are, or I would say where that's most impactful, is customers that are growing pretty quickly, and customers where the data engineering team, frankly, is swamped. It's very common for us to talk to, for example, tech companies or fintech companies where there's a 2 or 3 person data engineering team. They already have a ton to do. They just passed $500,000 or $1 million a year in Snowflake costs. And suddenly finance or management has come down and said, hey, you need to figure out how to get this down. You don't get any more headcount, and you still have to do your entire job that you were doing before. And so in a lot of ways, we come in and act almost like, an expert data engineer would. What we do on the back end is a little bit different. But really, if you want to be running things more efficiently, especially as you scale, where you should talk about partnering with us, because we expand what your team can do, and we kind of just take that off your plate, right? You don't need to worry about costs for a bit. You don't need to worry about cost growth nearly as much.
What does the onboarding process looks like for customers? How quickly can a new customer see meaningful cost or performance impact?
Yeah. So literally, as soon as you're onboarded, it can take us anywhere from a few hours to a couple days to train models. And then you pretty much just see the impact instantly. So we've literally had customers, come in, talk to us, and in 3-4 days, they'll be onboarded and running, and their bill gets cut in half.
Do you see this model is only going to cater to Snowflake, or you see a scope beyond Snowflake where you see Espresso AI evolve into a cross-platform cost intelligence layer?
Yeah, absolutely. So this is definitely applicable to all of data warehousing. So we're have a beta focused on Databricks SQL. If you're listening to this and you're like, oh man, I don't use Snowflake, I use Databricks SQL, but I absolutely need to fix how much that's costing, shoot me an email. Just starting to see some really interesting results there. More generally, BigQuery, Redshift, kind of all the big data warehouses have, to some extent or another, the same problem. Being able to come in and use models to understand, how exactly is this workload going to scale? Where really should I run this to optimize cost? In the case of BigQuery, is there a way to rewrite this to reduce the amount of data that it's reading, because the billing model there is a little bit different? ML can help with all of this stuff. And this is a little bit reductionist, but kind of the way that I think of it is LLMs understand code in a way that's much closer to humans. It's much closer to how humans understand code than how optimizers or compilers or other existing legacy static systems understand it. So really, any system that would benefit from having a strong data engineer look at every query or every workload, and that's everything, right? There's no data warehouse out there where someone is reviewing 1,000 queries a day. All of them are going to benefit from this technology, and we're planning to grow and bring it everywhere we can.
After listening to Ben, it's quite clear that cloud data costs are rising, but smarter infrastructure is finally catching up. And if Kubernetes for Snowflakes delivers, Espresso AI could be changing the game for everyone. Ben, thank you so much for these great insights, and I look forward to the next discussion. Thank you for your time today.
Thank you for having me. This was fun.